Use the definition of multiplication discussed in this section to explain why both of the following equations model the problem of determining how many squares make the rectangle in this figure 4.8. For each equation, state clearly what one group is and explain how you are viewing the small squares as organized into equal groups. Okay, let's take our figure. Two equations. And let's focus on the definition of multiplication. So myself a little space where A is the number of groups, B is the number of items per group, and then C is the total number of items. Okay, just in a most general way of speaking about it. Okay, so let's take a look. We have 6 groups of 9 squares for our first expression. So here we will need 6 groups of 9 squares per group. And that's going to be in the shape of the rows. Right, so we'll have 1, 2, 3, 4, 5, 6 rows. Each with right 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And we can show our row count since we're labeling. Okay, so 6 rows, each with 9 squares per row. And then that same image, right, because we just copy and pasted it, is 9 groups. Let's take our black. On this one, we have 9 groups of 6 squares per group. So we will this time we'll go for columns, right? So 2, same counting. We'll have 1 through 9 across the top and 1 through 6 going down. But this time we're grouping the columns. Okay, so this time we have 1, 2, you know where I'm going with this. Nine columns. With each with 6 squares in each column. Okay, so we've used our definition of multiplication to describe how each of these equations represented the array to begin with, right? So each of these equations is valid depending on which image you provide. Okay, let's go ahead and save this.